Creating a least squares line does not guarantee correlation between two variables. Also, identifying what the coefficient of correlation is does not guarantee correlation. Some additional steps in analysis need to occur. So in this lesson, we're going to take a look at 3 different ways that should be used together to ensure that there is a correlation between two variables. Those 3 ways are a coefficient of determination, residual plot, and box plot. So the first thing that I'll take a look at is the coefficient of determination. Let's start with the paragraph. The coefficient of determination, r squared, explains the proportion of total variation in the response variable found in the least squares regression line. So in other words, the coefficient of determination is a measure of how well the least squares regression line describes the relation between the explanatory and response variables. Remember, the explanatory variable is x and the response variable is y. The closer r squared is to 1, the better the least squares line describes how changes in the explanatory variable affect the value of the response variable. The coefficient of determination is calculated as r capital squared equals lowercase r squared, and then it's written as a percentage. So let's take a look at the table. The table says the coefficient of determination r squared is on the left, and I've come up with 3 values. Then their interpretations are over on the right. If I have the coefficient of determination, r squared, being 65.1%, then the interpretation is that 65.1% of the variability in the response variable is explained by the least squares line, and the remaining part, 34.9%, is explained by other factors. This is kind of concerning because 34.9% could be explained by other factors, so I want to explore that further if I have a coefficient of determination such as this. A residual plot places the explanatory variable on the x-axis and the residual value for each point on the y-axis. If the residual plot shows a discernible pattern such as a curve or non-horizontal line, then the explanatory and response variables may not be linearly related. A lurking variable may be the explanation. The next analysis I would do is a box plot. It's a box plot of the residuals. It helps us identify outliers. It's outliers of the residuals. Outliers are removed if they are the result of an error in recording, a miscalculation, or some other obvious blunder in the data collection process. The example that I'm going to work through is one that you've seen in your textbook. The example that I'm going to work through says, the Gallup organization regularly surveys adult Americans regarding their commute time to work. In addition, they administer a well-being survey. The data in the following table are based on the results of the survey, which represent commute time to work in minutes and well-being index score. Here I can see if there is a commute time of 5, then the well-being composite score is 69.2. As the commute time increases, the composite score decreases. I've entered the data into StatCrunch. I'm going to run a linear regression on this. Statistics, regression, simple linear. My x variable is commute time. My y variable is the composite score. This linear regression line fits the data well. Going back one screen, I can see the correlation coefficient is negative 0.981. If I square that value, I get 0.96138. Now going back to our Word document, you can see that I have that recorded. The coefficient of determination is calculated as taking the correlation coefficient, squaring it, and getting 0.962. This means 96.2% of the variability and the response variable is explained by the least squares line, and 3.8% is explained by some other factor. I'm going to draw in the residuals for each data point. This first point is above the line and would have a positive residual. The second point is on the line and would have almost no residual. The third point is below the line, would have a negative residual, and so would the fourth and the fifth. The sixth data point has a positive residual. The last data point is just below the line and has a negative residual. With technology, we can calculate those residual values. So I'll go back to StatDisk because I'm going to create a residual plot at this point. To create a residual plot, I'm going to go to my existing summary, go to Options, and edit this. I want to save the residuals. You can see that a new column has been created for the residuals. Now I'm going to create a scatter plot. The scatter plot is going to have the commute time as my x variable and my residual for my y variable. We can see that these points, these residuals, in relationship to the commute time, have no pattern. We have one on the far left, we have one on the far right. There's not a linear or a curved pattern to this. So that is great to see the residual plot having no pattern. The last thing I'm going to do is create a box plot. It will be a box plot of the residuals. And here I can identify no outliers with the box plot. So to summarize, I had the residual plot, and with the residual plot there is no pattern. That is great. It continues to show that there is a correlation between the commute time and the composite score. The box plot of the residuals also has no outliers. All three analyses indicate commute time and healthy weighs well-being index composite score are correlated, so the linear regression equation is valid for use.